Hello everyone, welcome to topic 5.11 or 5.11, catalysis. By the end of this, you should be able to explain the relationship between the effect of a catalyst on a reaction and changes in the reaction mechanism. So, a catalyst is a material that is used to speed up a chemical reaction but is not consumed by the reaction. Catalysts work in one of two ways. They can either alter the rate of the reaction by changing the number of effective collisions. There are two categories of catalysts, homogeneous catalysts and heterogeneous catalysts. A homogeneous catalyst is one in the same phase as the reactants and can mix with them uniformly. This is usually seen in a gas or aqueous phase. A heterogeneous catalyst is a different phase from the reacting particles, such as a solid catalyst with gaseous reactants. Typically, homogeneous catalysts provide a different chemical pathway so that the activation energy for the rate determining step is lower. We see this in the graphs below, where we have our general reaction, and then the addition of the catalyst does break it into two separate reactions, but it also drops that activation energy down significantly. So we have a much greater number of reacting particles available to react with the energy needed when we have a catalyst. So in this type of catalysis, the catalyst is used in one or more of the elementary steps, but is regenerated by the end of that reaction. Thus, it is not consumed overall and can be used to continue to catalyze more and more reactions. Another type of catalysis speeds up the reaction by binding with one or more of the reactants. This allows the reactants to be in an orientation that is more favorable for reaction, or catalase in the human body is one of these. This means that a reaction intermediate is formed that wasn't in an uncatalyzed pathway. You have probably studied catalysts in biology and they work in this manner. Enzymes are biological catalysts. Some catalysts work by creating a new intermediate by forming a covalent bond between the catalysts and the reactant. This occurs in acid-base catalysis and when a proton is transferred between species. This results in new intermediates and new elementary steps involving the new intermediate that did not form in the uncatalyzed pathway. So by using acids and thus a new pathway for this reaction. In general, a heterogeneous catalyst speeds up a reaction by altering the orientation of the molecules or providing an alternate reaction pathway that requires less activation energy. They do this by providing usually a solid surface that absorbs or binds with the reactants. Then the reactants diffuse along the surface until they find one another, and they are oriented in such a way that they can hit each other and react. So it provides a substrate to increase their announcements. I don't remember where I was with that, but they can then react, and through the reaction they are released because they no longer can bind to that substrate. Modern cars are fitted with catalytic converters that work in this method. They use a solid catalyst that's composed of platinum and rhodium. That's why catalytic converters are super expensive and people like to steal them. They reduce nitrogen oxides that are produced in the fuel burning process in a redox reaction to form unreactive nitrogen and oxygen gas that are then deabsorbed. They also contain oxidative catalyst that helps reduce the amount of hydrocarbons and carbon monoxide, and oxygen gas reduces the amount of nitrogen oxides in the atmosphere. Nitrogen oxides react with water in the atmosphere and produce acid rain. And so by the catalytic converters doing their work to react with these, it reduces the amount of pollutants in the air. So let's look at the IDUs. Okay. The rate of decomposition of hydrogen peroxide can be increased by adding a homogeneous catalyst. The reaction mechanisms occurs in two steps that is shown below. We are going to first write the overall reaction. As a reminder, to do that, you cancel out anything that is on both sides of the reaction arrow. So doing this, we cancel out these ones, and we check if there's any And this is our overall reaction. Now we identify the catalyst. Now remember, a catalyst is first used and then reproduced. So it should be appearing first in our canceled out bits as first a reactant, and then it's recreated as a product so we can keep using it. And in this case, that is iodide ion. And then our intermediate is the one that is produced and then reused. So it's first a product and then a reactant, and in this case, it is IO minus. That is, okay, so I want you, for this I want you to pause the video now and to try this on your own first, and then resume the video to check your work. Okay, so for this, you should see that you cancel out the things on both sides of the reaction arrow, and so this is your overall reaction here. Then looking for the catalyst is the one that is first a reactant, so it's used, and then it is reproduced so you can use it again, and that would be nitrogen monoxide. Then for our intermediate, it is the one that you make first and then you use up again in a subsequent step. That would be your nitrogen dioxide. Okay, so using these concepts, complete the UDOs. Thank you so much for tuning in. Okay, so for this, you should see that the catalyst is, this is our overall reaction. Our catalyst is first then used and then reproduced, and then our intermediate is produced and used. And then check your work, and thank you for tuning in.